Hello everybody, Charles Wallace here again. We're going to go into Lab 2. This lab will tell us how to install and upgrade the DSD server and software. So we're going to go through the DSD installation process, its requirements, the upgrade process, post-installation and upgrade tasks, and then some best practices here. So first thing we're going to do is install DSD. We're going to configure it to point to NTP, configure time zone, and then upgrade it. So as a VM here, there's some minimum requirements that must be met for the server to function within our specification. So for that, it's going to be based off of VM, so ESXi. And then each VM will have 24 vCPU. Typically we have 900 gigs of disk memory, and then for the lab here we're going to use 100 just to speed things up. We don't need that much space for what we've got to do. 32 gigs of memory. Coming up in the next release, we're actually going to support a version that will only require 8 gigs of memory depending on how many DMPs that you have. We're going to create a network interface, and I'll show you how to do that in VMware. And then we're going to set the IP address during the installation process. And this is important. If you were to install the director software and walk away, come back the next day while it was installing, it would just put some generic address in there and move on with the installation. So you want to make sure that you catch the spot in which it asks for IP address information and set it during the installation process. Otherwise, you have to take additional steps after the installation to change the IP address. Best practice, so SIMC, by default, when you get a 240 server out of the box, it is set to have the power off if you were to lose the server during a power failure for some reason. And this is problematic because if you have ESXi running and you got the C240 and you lost power to your data center, when it came back on, it wouldn't boot ESXi. It will just sit there in a powered off state. So it doesn't do anybody good if it's not running. And power outages happen particularly during the installation process in a new venue and all the time. So it's good to have this set. As far as the VM goes itself, you want to make sure that the VM is also set to auto boot after the installation. Otherwise, SIMC may power on ESXi, but ESXi by default won't power on the VM either. Another good practice here is to reserve 32 gigs of memory for the VM. And this is because VMware will allow you to over-provision VMs without regard to the physical memory that's in the server here. So if you're running Cisco Vision on a cluster with other VMs sharing the same hardware, it's possible that if you had, say, 128 gigs of memory in your physical machine, and Cisco Vision needs 32, and let's say you have another server that allocates 200 gigs, then they have to share for resources that aren't real. They do that by disk swapping, and the swapping really slows things down. So you want to make sure that you reserve all the memory that you can for director. It also prevents it from creating a swap file, which takes up extra space on the drive. So, you know, if you got a 1 terabyte drive, which is only 900 and something gigs to begin with, you may not have space for the swap file anyways. NTP. So NTP is required for DSD to function properly. DMPs also use it. And this is for synchronization for the script. So something has to have an accurate clock so that when you schedule certain things to happen, in the server, it's based off of some real time and not just a free running clock that's part of the server. Also, the DMPs will not function properly if they don't have accurate NTP sync. So that means they won't run a script, they probably won't boot correctly, they have to have NTP. The time zone, by default, the server is in the Pacific time zone. If you're in Pacific, that's great for you, but if you're elsewhere, then you need to make sure that you configure that time zone to wherever your server is at. And then once you change the time zone information, a reboot is required because all the processes are running at the time that it boots before you change the time zone, and their time is based off of whatever it was set when the server was booted. So you have to restart those processes, and the cleanest way to do it is just to reboot the whole server. As far as NTP goes, officially in our documentation, it should not be synced to a virtualized time source. So that's any time source that is an NTP server that is running as a VM. The best practice is to sync it to a time source such as a router or one of the atomic clocks on the internet that you can reach. So just keep that in mind. You know, in my experience, most people, most customers have their time set on their core, and then everything just points there, but it can be elsewhere too. And do not use a pool. So in our base installation, it's based off of Red Hat. So the configuration file has some default pools in there, and you really want to use your own reliable time source. These pools, you don't know where they might be, what, you know, if they're there today, tomorrow, if they work. And in my experience in the past, I've seen pools where the servers aren't always up. So you're better off just using your own and pointing to one of the NIST servers. Backing up DSD. So we're going to execute a manual backup right before our upgrade, and then we're going to create a nightly backup task. That way the server will back itself up automatically. So best practices, if you're going to upgrade, that you make this backup. Otherwise, if for some reason the upgrade doesn't go so well, you have a way to go back to where you were prior to the upgrade. The backup file contains everything that you need to restore Cisco Vision back to its previous state. Typically in an installation, you'll have a primary and a secondary server, and the best practice there is to decommission the primary server and take it offline, and then upgrade you promote the secondary server to a primary state, and then you upgrade the secondary server. You perform a round of testing, make sure that the upgrade was successful, and then if it is, then you go back onto the primary server and you upgrade it. It's a very safe way to upgrade, and it's worked very well for me in the past to upgrade like that. It's also possible to pull the file off with the help of Cisco TAC. Unfortunately, right now there's not a way to pull this backup file off through the software, so you'd have to contact Cisco TAC, and they would be able to help you retrieve the file for archiving if you wanted to be extra safe. So it's not a bad idea to give TAC a call if you're in a production environment, and you just pull that file off and put it on a thumb drive or your laptop for safekeeping, and that way you can make sure that if the worst possible scenario unfolded, you have a copy of it. Upgrading DSD, so you have to get the images from Cisco.com. These images are provided by me for this class right now, and I have them on my laptop. But if you were upgrading this in your own lab or in your own production environment, you go to Cisco.com and type in Cisco Vision into the software search. You'll see the DSD server as an option. You click on that and then it'll bring you to a link where you can pick the upgrade files for any release you might be coming from. Once you get them, then you'll upload them to the server, and there's an MD5 checksum that you have to compare with Cisco.com, and you just want to make sure that after you upload the server and you look at its checksum, that it does indeed match what you got from Cisco.com. It just prevents the possibility of accidentally installing a corrupted file for some reason. And then you're going to install the software. So it's basically point and click. You just click the upgrade after you upload the software, and then it will start installing. Typically takes about 30 minutes for this to occur, and afterwards you'll be upgraded. So that's it for the overview here. So we'll jump right into the lab, and we will have a look at our environment here for the first time, and we'll go ahead and get Cisco Vision installed. So I have used a different resolution on my screen so that you guys can see this a little bit easier in the split screen video here. So it may look a little bit bigger, and when we get into the UI, you might see that some of the windows are a little bit squashed together, and so we might have to deal with that, but it's better than using 1920 by 1080, so you guys can see. So we talked a little bit about the prerequisites here for the installation process. Is a little bit more here. So when you define your VM, you're going to set these options here. For processor, you want to make sure that you meet the minimum spec of 2.5 gigahertz or better. And it shouldn't be a problem if you order a Cisco UCS server. You can just look and see what type of CPU you got. They all match sort of this description here. You want to make sure that you write fast enough to the drive. When you're uploading content and pushing content and making changes to the system, it can be very intensive on the disk. So you want to make sure that your throughput is pretty fast. So if you are going to install Cisco Vision on an already existing or B series type cluster or some third-party cluster that's attached to a SAN, the one thing to keep in mind is that these servers, these UCS servers only have two 1 gig interfaces, so those are not appropriate for SAN activity with regards to Cisco Vision. You really want something that's a little more faster, and you probably don't want to put your management interfaces on the same interface as your SAN. So Cisco makes a whole line of these, what they call VIC cards, that fit into these chassis, and one of them is a 10 gig interface card, and you would use that for your SAN. You would avoid iSCSI over Ethernet, 1 gig Ethernet if you can at all costs. We did talk about the 32 gigs of RAM already, 8 gigs for a small installation of less than 1250 DMPs. When you define the VM, you're going to pick Red Hat Enterprise Linux 5, 64-bit. In the future, we're going to be changing this base OS, so always keep an eye out for that in the release notes to make sure that you are building the appropriate type of operating system for your VM. Network adapters, E1000. I have seen customers use the VMNet adapter from VMware, and it does all right, but this is our recommendation here. And then for the disk provisioning, you always want to make sure that you use thick provisioning for the same reason why you want to allocate all the RAM. You don't want it to run out of disk space. So thick provisioning will go ahead and provision the entire 900 gigs in the data store for the VM. If you were to choose the other option, which is thin, then it only allocates real disk space as it goes. So if for some reason you had a 1 terabyte drive and you built 2 servers and you gave each of them 1 terabyte of space, then realistically, if they both hit 500, then you'd be out of space, even though the disk says that it's 1 terabyte. So keep that in mind. We won't really be upgrading to 6.1. We're going to install 6.1 directly, but this here will just give you sort of an idea of the flow of how upgrades go in the Cisco Vision product. So our upgrade path is incremental, and you must go through every single service pack to get to where you're going. So for example, if you are on release 6.0 and you want to install release 6.1, you cannot simply just upload the 6.1 ISO upgrade image and then upgrade. Everything will get corrupted. So you have to install every single service pack, and in between from where you are and where you're going, and the place to find the upgrade path is in the release note documentation. So sometimes there is a shortcut, typically at the very end of the service packs. They may say, you know, you can go straight from service pack 4 to the release you're going to. You don't have to do service pack 5 or something like that, but make sure you really read the release notes to verify that you're upgrading the right path. So installing the DSD virtual machine here. So we're gonna log into our ESXi server here, and we're gonna browse for the data store, and then we're gonna upload it to Director. I've saved a little bit of time. I went ahead and uploaded the full install ISO here. Then we're going to set up the VM itself, and this is where we set up the disk size, the amount of memory you're going to use, the network adapter, and then like I said before, during the installation process, you want to make sure that you set the IP address, the net mask, and the gateway during the installation process. That way you don't have to go back and do it again. So with that, we will go ahead and open up our web browser here, and we'll go to our ESXi server, which is 10.10.100. So before we go there, let's just have a look at SimC for a minute. I want to show you some of the best practices information that I talked about before with the power on, and there's some other ones as well. So let's just go through that real quick. So this is SimC, if you have never seen it. There's a couple of key points that you want to look at before you install the Director server. And we're going to go over here and have a look. So storage. So here on our RAID controller, you can see that we have information here. You can see the drives there and the RAID configuration, the virtual drive. When you first get this thing out of the box, it's not going to have anything in here, and you can't configure it from here. So what you have to do is boot into the BIOS. So you'll turn the server on. It'll tell you to hit Control or Alt character during the boot process. I think it's Control H. And then when you're in that boot process, it goes into the BIOS, and then from there you can go into the RAID configuration. And what you have to do is make all the drives unconfigured, and then you can configure them and put them into a virtual drive. So I just have everything into a RAID 0 stripe, which has no mirroring capabilities, no redundancy. In a real installation, you would want to make sure that you're going to use either RAID 5 or you'll use RAID 10, which gives you a good bit of fault tolerance for a problem. The other thing to keep in mind here is with the Flex Flash. So the Flex Flash is a SD card that is in the server. So if you were to open the server up, you will see them on the side. You can have a primary and a secondary, and then they're mirrored if you have two of them. So with ESXi and with the UCS server, make sure you get the Cisco image for ESXi. If you do not get the Cisco image for ESXi, it doesn't come with the onboard drivers that you need for the NIC card. So it will fail during the installation process. The other thing that will make it fail during the installation process is the Flex Flash needs to be formatted before you can install ESXi. If you try to install it without doing this, then it will fail during the installation process. So you just hit this, put check mark in here, and you hit erase virtual drive, and that goes through and it makes it into a configuration that is acceptable for ESXi to install. So the power options here, let's just find that here. Power policies. So you want to, there's three options here. You want to do power off, power on, last state. Power off isn't a good one, that's the default. If you were to lose power, and it's separate power off, it won't come back on. So you either want to go for restore last state and power on. The difference in these two is with restore last state would probably help you if you had planned maintenance. So let's say, for example, you were having some power maintenance or whatever in your data center, and you went in here and shut this thing down on purpose, and that's the last state. You shut it down yourself. So they do some maintenance on the electrical system, and then it comes back on, and then 5 minutes later they turn it back off. And if you had power on set, every time the power came back on, it would come back on. So with restore last state, it would ensure that the server stayed off until you told it to come back on. And then once it's on, if it got rebooted, then it would go back to on. So that's the one I prefer, restore last state, but power on is probably fine as well. Okay, so then one more thing to keep in mind is with the boot priority here. So we need to look at the BIOS and the boot order. So you want to make sure that your boot order here says Flex Flash first. So Flex Flash is where you're going to install ESXi, and then other than that, you want to have KVM DVD. So these things don't come with DVD drives anymore. The way to install ESXi on here is through this Launch KVM button. I don't know if you guys have seen this, but it's a virtual terminal. We'll pop this open. There we go. This takes it a minute. And there it is. So this is what it would look like if you had a monitor and keyboard connected up to it. So going back to the KVM DVD, neither of these devices will exist when you first install the system. You have to go in and create the Flex Flash, and you have to go ahead and create the DVD. So you want to go over here and configure it. Configure tell it advanced. So here's where you would add it. So basically you just add a virtual media, and that will allow you to have the KVM DVD. And then the SD card is for the flex flash. So when you click add virtual media, you would just type whatever you want. You know, I just type KVM DVD. And then you want to pick in here KVM map to DVD. So if we click on one of the ones I created here, you can see there it is, KVM map to DVD. And then for the flex flash, it's the same way. You just add it, and here you go. Just enabled order one, and you save it. So, and you want the flex flash to be first, and then the KVM to be second. And then what happens is, in here, when you want to boot off of an ISO image, you tell it to activate a virtual device, and it's going to activate that KVM DVD that you created. And then you're going to map an ISO image to it. So you're going to map this. So I've already got ESXi, or there's a CentOS. It doesn't matter. We're not actually going to reboot the server here. So now you can see it's mapped. And then to get it to boot off of it, you tell it to override. So remember, Flex Flash is the first one. KVM DVD is the second one. You would just click that, and the next time the server reboots, it's going to boot off of that ISO image. So that's how you would install ESXi, and it would start booting. So these are just some best practices that don't really pertain to the lab exactly, but it's good to understand some of the configuration settings that you need for Director Tour, or sorry, ESXi to install. The other thing to keep in mind is the actual SIMC interface itself here. So when you click on here, you want the NIC redundancy mode to be dedicated. So what this means is that there's a few options, and by default when it comes out of the box, I believe it's set on shared LOM. So there's the two 1 gig interfaces on the UCS server, and then there's the management interface for SIMC. So by default, SIMC will run off of the 1 gig interface on board and not off of its dedicated port. The advantage of using a dedicated port is it's isolated from ESXi. If for some reason you have some unknown problem with ESXi and it's network related, if you have SIMC on its own port, then it's not likely that you would have the same networking problem on a different port. The other reason is you want to use untagged traffic for SIMC. This is so you can connect to it directly if you need to. On the ESXi interfaces, as you'll see here in a few minutes, they're actually going to be trunks. You can set the native VLAN to the same VLAN as what SIMC will be in, but it's still a trunk port, so there's still some complexity there and a little bit more that can go wrong if things go badly. And here's where you put in the IP address information. Pretty straightforward. So as far as SIMC goes, this is really all you need to know to get it up and working and configured. So now we're going to go ahead and log into ESXi. There we go. So I'll type in my root password here. And here we go. You'll first log in, and you'll have a screen that kind of looks like this here. You'll want to click on this navigator, and as we saw in the introduction lab, I have a few images here that I use for streaming and for our web services later on. So the first thing that we're going to want to do is go ahead and create our interface. So talking about the interface for ESXi, for best practices, you want to make sure that you set these up with port channeling I've used this in the past. The other method is to use active standby redundancy and ESXi. You can use them both. You'll achieve the same results, but if you ask me, the port channeling is better because you have the advantage of being able to use traffic on both interfaces at the same time. For my lab, I only used one interface, but in a real deployment, you're going to want to either use that active standby or what I prefer, the port channeling. So we're going to add a port group here, and we're just going to call it pod 101. And the VLAN ID, we're going to put 101 here. We're going to add that. So now we've got it. So that VLAN ID adds 802.1q trunking tagging on there. So we've got VLAN tags. And now we will go ahead and create our VMs here. So we're going to create a VM. Click next here. We're going to call it primary DSD. You can call it whatever you want. For the lab, we'll call it primary. We'll call it pod 101. In real life, I might stay clear from using the primary secondary terminology, and the reason why is because the servers might change roles. The one you start out with your primary may end up being your secondary, and it kind of confuses people if you go in there and call it primary. So you might want to stick with something more generic and just call it DSD on both servers, and you're agnostic of a primary and secondary role. That would be my best recommendation there. So we're going to pick Linux, and then we're going to pick Red Hat 5 here, 64-bit. Here we go. Click next. And we're going to just pick the data store. So this is obviously on board. One thing to keep in mind about ESXi, if you're installing it from scratch, you might have to add the data store. So if you remember, we have Flex Flash, which is separated from our RAID partition, which is the RAID 0 that's in there. And by default, ESXi doesn't detect the data store a lot of times. Very rarely, so you have to go in there and add the data store manually. So don't be surprised if you install an Flex Flash and then you go through this process and you see that the data store is not there. You can go in and add it pretty easily. It'll detect it. Customize settings. So like we talked about before here, we're going to pick 24 vPCUs. Memory, we're going to use 32 gigs. Hard disk, we're going to use 100 gigs. And we're going to make sure that it's thick provision, which it is. The memory, we're going to make sure that we reserve it. So we're going to reserve 32 gigs of memory here. And that looks good. Network adapter is going to be the one that we just created. It's connected. DVD. So we're going to pick our ISO that I pre-uploaded here. It's our full install. One thing to keep in mind, particularly with this, is after you install Director and you get your VM working, it doesn't unmap this data store file. And that can be dangerous. And the reason why is Cisco Vision will install unattended. So if you boot off of a Cisco Vision ISO, it goes right into the install, and one of the first things it does is format the drive. So you can imagine that if you still have this data store ISO file mapped after the installation process, it adds to the risk that you might accidentally boot off of it again. And if it's your primary machine and it boots off this ISO, it's going to format the drive. So you want to make sure that after the installation process that you unconnect it and remove it as an option here. So everything looks good here. We just double check it. Looks fine. So power management. Well, we'll talk about this here in a minute after we get it installed. So for now, we're just going to click next, finish, and it will be creating the VM as we speak. And there it is. So we're going to click on it here. Over here, right click, there's a power option here. Oh, sorry, there we go, enable. So that's what we talked about earlier where you know, when it boots, it'll just automatically start the VM, and you have to go in there and configure it, and you can change the order in which it starts. So we just want it to start with the system. Everything looks good there. All right, so now we're going to go ahead and power this thing on. Click on this console window so we get a little bit better view here. So it's going to go into the installation process, and like I said before, it's going to format the drive without any user intervention. So what I'll do here is I will allow it to go ahead and format the card and get to the point at which it asks for the network information. I'm going to pause the recording, and then once it gets to that point, I'll reinstate the recording and I'll show you how to configure the IP information. All right, everybody, so we're done with the format, and now we're at the point at which we must configure the network information. So we'll go back here, go to network configuration, hit the tab, and click Run Tool. So we're going to put in the IP information for ETH0. There's the default IP I was telling you about. So we're going to do 10.10.101.100, and then the gateway is going to be 10.10.101.1. No DNS here. We're not going out to the internet. Hit exit. And there we go. So it's bringing up the network interface, and it's going to install the rest of the packages. I will pause the recording again. This is going to take like another 30 minutes. It took about 15 minutes to do the format and get it to the point where we put in the IP address. So we'll all right, everybody. So it is done with the installation process. I'm going to go ahead and pull up our PDF here again. All right, so at the very end, we should be able to go to that address and it should pop something up here. So we'll just open up a browser, 10.10.101.100. See if we're successful here. And there we are. So we'll just have a login here. And the default username is admin, password's admin. May ask you to change it. You can just pick admin again. There we go. So what I did was on the switch, I went ahead and added the SVI interface. We do this in another lab. I have it listed. And if you were taking my training class, I would go ahead and do it for you. But so here it is, if you guys want to see, you know, some of the commands. And then we needed to enable NTP so that during this next step in the lab, we can get an NTP source working. So configuring NTP, we're going to log into the console. So this is the 2E. The 2E is the graphical user interface, or sorry, not graphical, it's a text user interface. And it's based off of a Linux shell, and you log in and it's menu driven through, you know, keys on the keyboard. We're going to go to that date and time setting there. We're going to set up an NTP source. We're going to uncomment out the pool addresses that we talked about earlier. We're going to put in our server's gateway, and then it'll synchronize. When that's done, we're going to configure the time zone. So we're going to find the time zone code, and then we're going to get it there. You see how it says America, Detroit, or if we're here, it might say America, New York. And we're going to put that in there, and then we're going to reboot. So let's go ahead and do that. So I'm going to bring up a window. I'm going to log into it. 10.101.100. Installer, Cisco, exclamation point 123. And there we go. See, our IP address is set right. So we're going to go into account settings here, or system settings. I'm going to go into date and time, set up an NTP source. We're going to go down here, we're going to comment out the pool addresses. Server 10.10.101.1. There we go. Save it. Now it should synchronize here. If you look at these messages here, you can kind of tell what it's doing. So there was a success, and then here we can see here that there was an offset from the current time of 25,000 seconds, and it set it. So the time was reset minus 25,000 seconds. So it was successful. Now we're going to change the time zone. We're going to find the time zone codes. We're going to go to Americas, 49 for the U.S., Eastern most areas. So there it is. So this is what we want. America, New York. Yes. So now we got to go and change the time zone here. And it says America, Los Angeles, but we're going to put in what I copied, New York. And there we go. So now we're going to reboot it. We're going to go into server administration here, so that's D, and L for reboot. Yes. So now the system's going down, and this is probably going to take another 10 minutes. So I'm going to pause the recording. And here we go. We're back at the login prompt. So the next thing we're going to do is create a manual backup. So to do this, we're going to log in. We're going to go to the management dashboard. That's going to pop up. Then we're going to go to Tools, Advanced, Run a Task, Backup Task, and then we're going to click Apply. So I'm not really logged in because we rebooted the server. Admin. Management dashboard's under this cog over here. Management dashboard. So here we go. Tools, Advanced, Run a Task, and there's Backup Task. Hit Apply. Now the server, there's creating a backup. It's going to be stored locally, and it won't copy it over to the secondary unless you were to set that up. We don't have a secondary server, but it's possible to set up the server to copy the backup files over to the secondary server once the backup is done. So we'll see if the backup's finished. We're Restore data from backup. Let's do a refresh here. And there it is. And you can see the time is correct, so we know that our time synchronization task was successful. And there's our backup. So the next thing is we would restore it from a backup. We're not actually going to restore it. There's no need to for this step. We would keep that backup for the upgrade. If something were to happen and the upgrade would fail, we'd be able to pull that backup off, and then we'd be able to restore it on a different system, a new installation. So anyways, this is where you would go to do it though. So you just click restore, you click that, and you don't want all these files, so all components. You hit apply, and it's going to restore that database. So upgrading, so like I said before, you'll go to cisco.com, you'll pop in Cisco Vision, should kind of auto fill in director below you. You'll click on it, it'll take you a page that looks like this, download software, and then you'll have all these releases over here. You get the latest one, and then all the subsequent ones, and when you comb through them here, you will see the different releases. So you got these language packs, and there's Service Pack 1 here. There's FCS upgrades from the previous release. So you just kind of want to pay attention to that if you're going to upgrade, which ones you need. Like I said, if you're going from one release to another, you got to install subsequent service packs in between, and then you can get to your final release, whatever you're going to. So I'm going to go ahead and upload the software that I've got for the upgrade, and then after it's uploaded, we're going to see that checksum, and you would go back onto the Cisco Vision site, and there's a checksum in there. Compare that checksum, and if it matches, you click install. So we're going to go over here to our page that we get into when we first log in. Click on manage software, and we're going to upload this file. So we're going to go to our desktop. There we go. So I'm going to pick this upgrade file here. So this was the full image that we imaged it from, and then this is our upgrade file. So we're going to pick that, and it's going to upload it. So you go ahead and upload all the files that you get, and then you install them one at a time. So you'll see it when it's done, it'll just show you the file there, and then its status. And then when you click on it, you'll click install, and it'll install it. So usually it takes about 30 minutes to do the installation, and then once it's complete, you'll be able to log back in and see the version number. So on the home page here, when you log in, it'll show you your version number. There you go. See, we got 6.1.0.265, and we're going to, that's 265, that's our base install, and now we're going to go to 6.1.0-363. There we go, I got 60 something percent. Shouldn't take much longer here. So like I said before, if you're going to do this in real life, this would be the standby server. The primary server would be shut off, And by the way, when you do the upgrade, your standby server has to have the IP address of the original server. So if our primary is .100, our secondary is 101, when we shut down 100, we would need to make 101.100, and you do that through the UI, the TUI here. Let me bring it back up. So under system settings, network settings, set up manual network information. Edit devices is the same thing you saw during the install. You can change it from if it was the secondary, you'd say 101, make it 100. Click OK, save it, and then reboot, and you're good to go. So here we go. So our upload is complete. We're going to go ahead and click on it, and we're going to click install. And you can kind of watch this log. It looks a lot like the installation from the full ISO image. It's just going to kind of go through here and install these packages, and at the very end it'll pop up a message that says upgrade was successful. And once that's done, you're upgraded. So typically during a real upgrade situation, you'd verify everything's working right, and then you'd make a backup, and then you would demote the server back to 101. You would make 100 powered back on, and you would upgrade it, and then you would restore the database. Well, why restore the database? Well, during the upgrade process, you have to upgrade the firmware. And you have to reboot, so they may swap IP. So you want to get the latest database of what the server state was from the secondary, and then put it on the primary. So that's it for this lab. I'll just let this go ahead and finish, and then when it's done, we'll pick up and we'll start on the next lab.